This is a video of Chapter 4, Section 5, page 2 of the bookwork. Explain the relationship between mass and inertia. Mass is the measurement of inertia. Inertia is the resistance that matter has to changes in state of motion, and it can be measured in kilograms. So mass is matter, and matter is measured in kilograms. The pillow and the car battery, mass is not volume. Mass is matter, and volume is more related to density. And a car battery is much more dense than a pillow. But the kilograms is what you would look at specifically, not the density and not the volume. What is mass? Mass is the amount of matter of an object, and it's measured in kilograms. What is weight? Weight is the force of gravity on an object, and it is measured in newtons. That can change depending on where you're at. Is your mass and weight on Earth the same as your mass and weight on the moon? Your mass is the same everywhere, so your kilograms are always going to be the same. But the force of gravity, for instance, on the Earth is greater than your force of gravity on the moon. Of course, if you're out in space, and if we said a force of gravity in space, then there's no net gravity in space. Is a kilogram a measurement of mass or weight? We already said that mass is measured in kilograms and weight is measured in newtons. This is the conversions. So on Earth, 1 kilogram is 9.8 newtons. 10 kilograms, typo, 10 kilograms is 98 newtons. And then 100 kilograms is 980 newtons. Which brings us to this, which is another typo, 2 in a row. The force of gravity on Earth is equal to our mass times a negative 9.8 newtons per kilogram, and that is Fg equals mg, and that g right there is the 9.8 on Earth. Net force. Net force is the total of all forces. Sometimes you see it written like this, net force, or you can also say the sum of all forces. Figure 4.1 on page 51 has forces like, for instance, 10 to the right, 5 to the left is going to be equal to 5 to the right. 10 to the right and 5 to the right is going to be equal to 15 to the right. And then the last one brings us to equilibrium when net force equals 0. So if you have a negative 5 and a positive 5, then your result is simply 0. And that's equilibrium. Which brings us to a book resting on a table. It's not accelerating. So if an object is not accelerating, the net force is 0. So if this book is resting on the table, what you're going to have is you're going to have the force of gravity going down. We'll call that Fg. And then you'll have the support force called the normal force going up from the surface. And so from the surface of the book, the normal force is in the opposite direction. So once again, your net force is 0. So that's why it doesn't accelerate. It does have a force on it, but the net force here equals 0. And since acceleration is proportional to your net force, if they're all 0, then it's not going to accelerate anywhere. So that's what equilibrium has to do with the idea of net force. If your forces are balanced, right, you might have a lot of forces on something, but if the forces are balanced, then your net force equals 0. You won't get an acceleration. But if they're unbalanced, you will get an acceleration. The last thing talks about these two figures, and both of them are talking about, like, for instance, if I have 10 newtons down, I can either counteract that with 10 newtons up, or I could do 5 and 5, and that would be the same as 10 down. The end.